Let us look at a reduction formula method of integration. Reduction formulas are recursive relations that express a complex integral in terms of a simpler one, typically with a reduced power or fewer variables. So let's understand this with an example. Let's say we are given an integral I is equal to integral sine to the power of nx dx, where n is a positive integer. Okay, so what we'll do is we'll split this sine to the power of nx into sine to the power of n minus 1 x and sine x. So our integral becomes a product of two functions. And now we use integration by parts. So for that, we need to choose u and dv. Now remember the Eilert principle, but here both are trigonometric. So here we will choose dv as that which is simpler to integrate. So that u becomes sine to the power of n minus 1 of x and dv is equal to sine x dx. Now differentiating u, we get du is equal to n minus 1 times sine to the power of n minus 2 of x cos x dx. And integrating dv, we get v is equal to minus cos x. Now we apply the formula for the integration by parts. We get integral of sine to the power of n minus 1 of x times sine x dx is equal to uv. U is sine to the power of n minus 1 of x times v. V is minus cos x minus integral of v. V is minus cos x times du. Du is, where is du? N minus 1 times sine to the power of n minus 2 x times cos x dx. Okay, now we simplify this. So what simplification we have carried out? This minus we have brought it to the front. Minus times minus is plus. N minus 1 is a constant, so we take it out of the integral. Cos x times cos x is cos square x times sine to the power of n minus 2 of x dx. Now this cos square x, we take it as 1 minus sine square x. And we open up the bracket so that we get sine to the power of n minus 2 x dx minus sine to the power of 2 plus n minus 2, which gives us n x dx. And now we split this integral into 2. So n minus 1 is common to both. So n minus 1 times the integral of sine to the power of n minus 2 of x dx minus n minus 1 times the integral of sine to the power of n x dx. But this is nothing but the starting point I. So let's substitute it with I. So we have n minus 1 times I. And since on the left hand side also we have I, let's bring it to the left hand side as well. So I plus n minus 1 I. The rest remains as it is. Now here I plus ni minus I. So I minus I cancel out and we are left with ni. So we get n times I is the integral sine n x dx is equal to minus sine to the power of n minus 1 x times cos x plus n minus 1 integral sine n minus 2 x dx. And now we will take n to the other side. So that we get integral of sine n x dx is equal to minus 1 by n times sine to the power of n minus 1 x times cos x plus n minus 1 by n times the integral sine n minus 2 x dx. So basically, this is what recursive means. While solving the integral, we end up with embedded integrals and we keep solving it. So let's take one more step. Repeating the reduction process for the second term in the RHS gives us. Now, why are we repeating it? Because we started with sine to the power of nx. Now we have integral of sine to the power of n minus 2 x dx. If we repeat it again, we will end up with integral of sine to the power of n minus 4 x dx. So the powers are reducing. Okay. So when we do that, we will end up with in is equal to, the first term was already there, and these two terms have come up by integrating this. But in the last one, we have I sub n minus 4. So n minus 2, n minus 4. That means if we keep repeating the above process, say m times, we will end up with I0 or I1. That depends on if n is even and we keep reducing it by 2, what will happen? An even number repeatedly subtracted with 2 will end up with 0. So I0 will become 0. Or in other words, here, as we keep subtracting 2, the even number will reach 0, so that we end up with integral of sine to the power of 0 x dx. That is nothing but 1 dx. And 1 dx is nothing but x. Okay. But what happens if n is odd? If n is odd, repeatedly subtracting it with 2 will give us finally what? It will give us sine x dx integral. And integral of sine x dx is minus cos x. So this is the process. Now to summarize this, the repetition of reduction formula leads to the power of sine decreases by 2 each time. The numerator gains a new descending odd factor each time. So if you notice here, we started off with 1 by n, n minus 1 by n times n minus 2, n minus 1 times n minus 3 by n times n minus 2. So here, as we keep repeatedly applying the reduction formula, n minus 1, n minus 3, n minus 5, and so on. So each time the numerator gains a descending odd factor. And similarly, the denominator gains new descending even factor each time. So we started with n times n minus 2, n times n minus 2. Here it may not look as if it is picking up another descending even factor, that is n times n minus 2 times n minus 4. But that will happen once we take care of I sub n minus 4 in the next iteration. Okay, so the coefficients are products of these ratios. So here 1 by n on its own is the coefficient. Here 1 by n is repeating, and n minus 1 by n minus 2 is another ratio that is coming up. So the coefficients are products of these ratios. And as we have seen, if n is even, the process ends with I0 is equal to x. And if n is odd, the process ends with I sub 1 equal to minus cos x. Let us solve two problems. One where the power of sine is an odd number, and one where it is an even number. So let's take the first one. So we have I is equal to integral of sine to the power of 5x dx. So here n is equal to 5. So applying the reduction formula, minus 1 by n, that is 5, sine to the power of n minus 1, which is 4x, times cos x, plus n minus 1 by n, integral of sine to the power of n minus 2 x dx. Now, simplify whatever we can. First term remains the same, plus this becomes 4 by 5 times, applying the formula again for sine cube x. So minus 1 by 3 sine to the power of 3 minus 1 x cos x, plus n minus 1 by n times n minus 2. So 3 minus 1 divided by 3 times 3 minus 2 times the integral sine to the power of 3 minus 2 x dx. Let's simplify that. We get 4 by 15 and minus times sine square x cos x, plus 3 minus 1 is 2, 4 is 8. 3 minus 2, 1 times 3 is 3, 3 times 5 is 15, times the integral of sine x dx. And sine x dx, we know the integral. Our result becomes minus 1 by 5 sine to the power of 4x cos x, minus 4 by 15 sine square x cos x, minus, because integral of sine x is minus cos x, so minus 8 by 15 cos x, plus c, the constant of integration. So that is for a power of odd number. Now let's look at the second problem. So we have I is equal to integral of sine to the power of 6x dx, and here n is equal to 6. So applying the formula, minus 1 by n sine to the power of n minus 1 x cos x, plus n minus 1 by n times the integral sine to the power of n minus 2 x dx. So simplifying, we get minus 1 by 6 sine to the power of 5x times cos x, plus 5 by 6 integral sine 4x dx. Okay, so which means we have to apply the formula again. So now 5 by 6 is the common factor for this entire thing, and applying the formula, we get minus 1 by n, that is n is now 4. So minus 1 by 4 times sine to the power of 4 minus 1 x cos x, plus 4 minus 1 by 4 times integral of sine 4 minus 2 x dx. Okay, simplifying it, what do we get? This up to here it remains the same. This becomes 3 by 4 times sine square x dx integral. Up to here it remains the same. 3 by 4 becomes a factor for everything inside this bracket. Applying the formula to sine square x dx, we get minus sine to the power of 2 minus 1 x cos x by 2, plus 2 minus 1 by 2 times integral of sine to the power of 2 minus 2 x dx. So here this becomes 1 by 2 times integral of sine to the power of 0 x dx. Now sine to the power of 0 x is 1. So which means we have an integral of dx. So integral of dx is x. So 1 by 2 x. Now we start opening up the brackets. So we have minus sine to the power of 5x by 6 times cos x, plus 5 by 6 minus sine cube x times cos x by 4, plus times minus, minus 3 by 8 sin x cos x, plus, now here we will have 3 times 1 is 3, 4 to 8 is 8. So 3 by 8 x. Now let's open up the next bracket. We get minus 5 by 24 sine cube x cos x, minus 3, 2, 6, 8 to 16. So 5 by 16 sin x cos x plus again 3, 2, 6. So 2, 8, 16. So 5 by 16 x plus c. So that is the result of integrating sine to the power of 6x dx. That was the reduction formula for sine nx. If you found this useful, don't forget to like, share, and subscribe. Questions and suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.